We are talking about 3.2, which is linear functions, and this is going to be our last section of linear functions. So we're going to start by talking about the solution of a linear equation in two variables. We've seen linear equations, or just equations, where we had one variable, where we only had x's. But we are working with linear equations, and that has two. So it has x's and y's, and a solution is an ordered pair, which is x comma y, that makes the equation true. So I have some value of x and some value of y that makes the equation work out. There are two different kinds of domain. We talked about domain before, and a domain is any value x could be. So we have a discrete domain, which is a set of input values that consists only of certain numbers in an interval. So it's only some of them, it's not all of them in an interval. So if I have a number line here, and that represents x, my domain is only these points. It's not everything in between, it's only those. So it's only certain points. It is discrete. It is separate. They are certain points. Now, if I have a continuous domain, that is a set of input values that consists of all the numbers in an interval. So on my number line here, I would have my two endpoints, and it's everything in between. So here you can have partial, you can have a fraction, you can have a decimal, but here it is only certain points. Now let's look at an example. Let's say the linear function y equals 25x represents the cost y of x number of tickets at a theme park. Each guest can buy up to or a maximum of 3 tickets. We're going to find the domain. Is it discrete or continuous? And we are going to graph it using the domain. So I'm going to start by making a table of values. So I have where x is 0. If I don't buy any tickets, I'm not going to pay any money. If I buy 1 ticket, I spend $25. If I buy 2 tickets, I spend $50. And if I buy 3 tickets, I spend $75. So the maximum number of tickets it said I could buy was 3, so I'm going to stop at 3. I did not include any negative numbers here because I can't have a negative number of tickets. And to get my y values, I put x into my formula, and then my output is y. Now to graph it, so let's talk about the domain. It is discrete because I can't have a partial number of tickets. I can't have 2.5 tickets. I either have 2 tickets or 3 tickets, but I can't have 2.5. So it is discrete. Then to graph it, I would plot my points. I have my x values and y values, and those make ordered pairs, and they are plotted here on the graph. Another example says, a taxi ride costs y equals 15x plus 7 for x number of miles. Is this linear? To tell if it is linear, I want to see is it in y equals mx plus b. Yes. My slope here would be 15, and my y-intercept is 7. Now, after I look at that, I look at my x. Is it a regular little x? Yeah. Does it have any exponents on it? No. So, it is linear. So it is linear. We know that. Now, is the domain discrete or continuous? Can I have partial number of miles? Yeah. I could go 2.5 miles. I could go 1.98 miles. I don't have to go just 1 mile, 2 miles, or 3 miles. So then to graph it, I'm going to start with a table of values, the best way. And so using my formula that it gives, and using these x values to put in for x, I get out my y values here. I just chose numbers. I could have chose 1.2, 2.4, 3.87 if I wanted to, and then I'd get different y values. But I just chose 0, 1, 2, 3. Again, could I have a negative number of miles that I drove in the car? No. Even if you drive backwards in a taxi, you're still going a positive distance, so it would be a positive number of miles. So then I can graph it, and I have the graph that looks like this. And I would connect it this time because I can have any number of miles in between those points. And that shows that it is continuous.